Now let's try to read about if-else block and how to create loops in Python. Here is the example of an if block. If block is made to execute some part of a code which you want to be executed if a certain logical condition is met. For example, if I say hi to someone, then I am assuming the other person will say hello in text. Similarly, if the other person says hello to me, then I will say hi. So how can we execute such logical condition in our code? We can do that by using if-else block. So if-else block actually also have an else if in it. So how it run is with the if keyword, we give the first logical expression, and if that logical expression is true, then the code inside the if block gets executed. All the other blocks will not be get executed if the if statement is true. Next comes the else if block. If the above if statement is not true, then the Python will read the logical expression in else if condition. If the else if logical expression is true, then the code within the else if block will get executed. Rather, if none of the if and else if blocks are true, then finally the else block will get executed. Note that you can write only one if and one else block, whereas you can write as many as else if block in a if else block. Let's try to code this and see the practical example with some code. Here is our file. Let's try to implement the code. We can say a variable, a string variable, say reply. And this reply is hi. If the reply is hi, we want to say is hello. So let's just first try to run this part of the code. We saved it. Now open the terminal and write python 3 name of the file hello.py. And in the result we got hello because this if statement was true. Now let's say if hi has two eyes. Now run our code again. We don't get any output because our code never went inside this if condition, and that's why nothing was printed. Now let's add an else block, and where we'll say if we don't get a high, then we should say try. Let's try to save it and run this program. As you can see, we got by in output because the if condition was not true, so by default the code went into the else block and the code present inside the else block was executed. Now let's try to add an else if block. Else if, we say it as else if, but we write it as ELIF, is a short form for else if. Now say reply is equals to 2 times I into the high. Then we will say hello there. Now let's try to run our code. And again, as you see, we got by in output. This is because our reply was high only. So none of the condition was met, even the if nor in the else if. So by default, the code went into else block. Now let's change this into high. Only the hello was printed because the code went from starting to end and the first if was executed. So it did not look for any other else if. So let's change this to one more I. Now hello there was printed. This is because the first if was not uh, true, but the next else if was true. That's why the code went into the else if block. Now let's try to add another else if block with the same condition, but with some different result. We can say by there. These two conditions are same. Let's see whether the code will go inside them both or not. We only got hello there. This is because the else if condition was true here and the code stopped looking for any other true statements. That's why we only got one output. One thing to note that in our text editor, whenever we go from if block to the next line inside the if block, the text editor automatically tells us a place where to write our code. Like the print line is not starting as the same as the if position. This is because in Python, this is the way how you indent the code. This is just not just only for your readability, but this is how the Python wants the code to be. If I place this Python to be here, let's save this and delete everything. First of all, the code editor already told us that this print is an error here. Let's try to run our program. It gave us the indentation error. This is the indentation error is same as what we are talking about. The code must be intended as if we are going inside the if block right after the colon, then we should leave at least 4 spaces or one tab. 1, 2, 3, 4. It should be 4 spaces or 2 spaces or one tab. But in text editor like Visual Studio Code, it will automatically tells you the next position where you should write the code. So you don't need to worry about that. But you need to remember that these indentation are not just only for readability, they have some meaning. Let's save this and let's go back to our slide. Next, we have for loop. In for loop, we have an first thing is an iterator and the next is an iteratable. So to execute an for loop or to make a for loop, you need two things, an iterator which will iterate from starting to end position and an iteratable which will provide those location, the starting location and the end location. Here I is a variable which is an iterator whose value will get updated according to the iteratable. The iteratable here is range 5. Range 5 is a function which gives us the values from 0 to 5 without including 5. So the range will actually make the value of I to be as from 0, then 1, then 2, then 3, then 4. So the I value in every loop will the I value will start from 0, then when the for loop ends, the I value will get updated and it will be 1, then it will be 2, then it will be 3, then it will be 4. And when it reaches the 5, the for loop will end. So basically, when we'll run this code, because this for loop will run 5 times, the print hello world, which the program we wrote inside this for loop, or should we say the for loop block, will get executed 5 times. So let's write this code and see if it works like that. Let's clean this. We say for I in range 5. Now let's print our hello world. Now run our code. We saw hello world to be printed 5 times. This is what we expected. Now see how the I values are changing. Let's also print I along with that. So now we are printing the value of I every time in the loop, in the for loop with the hello world. Let's save this file and run this code again. We saw the value of I is actually increasing. It's going from 0 to 5. And when it hits the 5, the for loop ends. And every time it goes from starting to end position, the code inside the block is being executed. So this is how we write the for loop in Python. It is one of the most important thing and even in programming to write a loop because everything eventually you'll be using in for the for loop. So please try to remember this statement. For then iterator, the variable for iterator who will save the iteratable values and then an iteratable which will provide the starting and end position. Let's get back to our slides. Similarly, we have a while loop in Python. As for loop runs till it reaches an endpoint, we can create a while loop which can run indefinitely. So we don't generally want our code to run indefinitely. So to get out from a while loop, we use a break statement. Let's write the code to understand more about this while loop. The while to write a while loop, first keyword to remember is the while only. So while you use this while keyword, then until the statement or the logical expression after that while is true, the code will be executed. So let's fix this as true. So this is more fixed value. So our loop will continue and our loop will keep on running because this while loop is always true. So let's test this. X is equals to x plus 1. Let's define our x outside a loop. And if x goes above 10, then we say break. And while these values are getting updated, let's try to print them too. Let's save this file and run it and see what will be the result. As you can see, the x value in the starting was 0, and then the code entered inside this while loop, and this while loop also follows the same indentation as the if and else block were following. Similarly, here we updated the x values to be whatever they were earlier, added 1 inside them. So initially the x was 0. Here the value of x became 1. Then we printed the value of x. So we got 1 here, and we keep doing that and until the x value was greater than 10, which means when the x will be 11, we went inside this if block and we added a break here. Break is another keyword which we use to get outside of while loop. We can also use the same break keyword for getting outside a while loop, for from outside a for loop. So break will always break any kind of loop. Here we are using it to break from a while loop, and that's why we only got values till 11. Let's try to use this break in our for loop. For x in range of, we can say 11, we can say 100. And here, if we write the same thing, if x is greater than 10, we should break, and we can print here the value of x. As you can see, we don't update our x with within the for loop because x is an iterator now. It will automatically get changed after every time this code is run, and this code inside this for loop will run for 100 times. But we have added an if statement which says if the x value goes above 10, which means when the x value is 11, break this loop. Let's save this and try to run our code. Now we got the values from 0 to 11. This is because the range starts from 0. That's why, and then we print the value of x. The value which started was 0. Then at the end, when it reaches the 11th, when the x value was 11, it went inside this if statement, because if if statement was true then, and we hit a break command which broke the loop, whatever loop we were. Right now we went for loop, that's why the code stopped working here and we only got the value from 0 to 11. Let's get back to our slides. So remember that break is used to come outside of any kind of loop. And with this condition, the true, which we gave as a fixed value, we can also vary that and can stop our while loop using that. Now let's write some function. If you don't know what a function is a thing which we write which minimizes the piece of code which we will write in future by making a piece of code executable with the function name. So it's something like if you have 100 lines of code and that needs to be executed for every 10 students or 10 students or something, which needs to be executed for 10 times. So we can write them inside a function, and when we can call these functions, that will actually run the piece of code again and again. But we don't have to write the whole 100 lines of code again and again to execute the same commands. So let's try to write our function in Python. Before writing that, we must know in the function we have two things. First is write. We use a define keyword to define any function. As Python is very close to English language, That's why the keywords are almost what we use in English. So to define a keyword, we use a def, 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 then the name of a function, then we use a parentheses, and inside these parentheses, we give, we use some arguments. These arguments are the one which are the variables which you can use inside your function block. Then when you give this arguments, uh, then when you call your function at that time, you pass the argument. So while defining a function, you were declaring arguments and saying whatever the x will be in our piece of code, we can do um, some math, some coding on that variable. And while using that function, we can pass these values to the x directly. So let's write our code to get more understanding of this. So let's say we want to make a function which adds two numbers. So we can say we can obviously do an we can use an add operator, but let's try to create a function for that. So if we want to say add x comma y, when future we know that these x and y uh, can be integer or can be a float. So let's print x plus y. We have defined, let's save this and run our code. We don't get anything here. This is because we have just defined our function. It is ready to be used, but we haven't passed any arguments for our function. The value of x and y are still variables. So now let's use our function and pass some arguments to get the value. Let's say add x, and we can say x is 10 and y is 12. We don't have to actually equate our x and y here. We can just pass them at the position they were defined. Now let's write our code. Uh, let's run our code and see we got 22 printed. That is the sum of 10 and 12. So this is the place where we defined our function, and this is a place where we called our function. Now the function needs to be defined only one. We can call our function as many times as we want, and every time we can have a different value. And let's save our file and run it, and we get the sum of all of these numbers printed while we only declared this print x plus y once. So this is how we use functions. Let's write our function again when now we'll use a return keyword. Let's know what is a return keyword. We can say multiply x comma y, and we can say here x into y. Now, as you can see, we are not printing anything. We use a keyword called return. As in English, return means giving back. Similarly, in Python, return means whenever we run this code, in return, we will get this value. So whatever this value will be, the variable values which be in front of return, they will be given back to the main code. So let's try and create a variable called answer, and right now is 0. And then we can say answer is equals to multiplication of 10 comma 2, and then we can print our answer. So whatever, when this function will run, it will multiply the value of 10 and 2, and will return the value of 10 into 2, and that return value is equals to answer. So the answer will get up, the value of answer will get updated to the returning value, and when we'll print it, we'll get the result of this function. Let's run our code. So we got 20 here. This is because 10 into 2, the value got saved in answer variable and we printed it and we got 20. So this is how we use a return keyword. Let's get back to our slides. So this is how we define our function. Let's get to know more about these functions. Earlier, the way we defined our function, it might take a lot of uh, lines in our code, and in Python, write something in one line is quite famous. That saves your user's readability and actually your time to write that function. Imagine if you want to write an equation of line. In math, you can directly write it as y equals to mx plus c. So to make it more closer to what we actually do in math or in English, you can use a lambda function. These are also called anonymous function. They are just, you can use some simple expressions uh, and make a function from them. Like the line is a simple expression. You don't need to create a whole function to get the value of y value for every x in a line. So we can write a lambda function instead of the whole uh, defined function, and we will have the same function which we want. And defining the function like using the lambda keyword, and those functions are known as lambda functions. Now let's open our text editor and write the lambda function. So we can write the same line expression as we know line is equals to mx plus c, but we cannot directly write like this. So let's create this as a lambda expression or a lambda function. So y will be finally the function, the name of the function. Then we use a lambda keyword. Then after that, we don't need to give a parentheses. We can directly give the variables which we will be using in our expression. So to write a line, we need a value of slope m, then value of x, then a constant. Then we can say this value is will be equals to the whatever y for particular m, x, and c will be m into x plus c as the equation of line. And now let's print our function value for some m and x and c. Let's say our m is 1 and x is 1 and c is also 1. So for y should be m1 into 1 plus 1, it should be 2. So in result, we should get 2. So we got result to be 2. So this is how we write our lambda functions. Let's get back to our slide. So lambda was a keyword here, and the arguments were given right after the lambda keyword, and the final expression was given after those arguments like this. As we had a different type of variables in Python, similarly, we have something called data structures. These data structures collect and assemble these data variables. You can imagine them as an upper envelope from the data variables. So uh, there are different type of data structures which have different functionalities, and they are used in different ways because of their unique features. So here we'll study about these data structures which are in Python one by one. Let's start with list. So to create a list, we can have, as we started with a variable, we give a name, then equals to, then we use a square bracket, and within the square bracket, we can put any kind of arbitrary type of data variables, and we can separate one variable from other using a comma. So the list can be of infinite length in theory. So you can put as many as element if you want inside the list uh, using this way. And when you print the list, you can directly call the variable which the name of the variable where the list was stored, and you'll get list as printed. Now let's try to write some code and see more about the list there only. Let's try to create our very first list. And let's name it as L. And after L equals to, we have a square bracket. And within the square bracket, we can have different type of values. Let's say 1, then 1, and as a string, then we can have um, 2 as a character, then 34. So the data type can be anything inside this list, and they are separated using a comma. Let's print our list using the variable L, and let's save our code, and let's see what our results will be. So Python 3, name of the file, don't forget the .py. So here we got the same list in our terminal after we printed that variable. So this whole thing got printed because we printed the list variable. As we studied in the strings that the counting in the Python starts from 0 rather than the natural counting which starts from 1. So to access an data variable inside this list, we use a square bracket right after the name of this variable. And here in the square bracket, we give the index of the position of the element which we want to print. Let's say we want the first element. So we'll give 0 as an index, as 0 is the initial index in the Python. Let's save it and run our command, run our file, and we got 1 as output. As we studied in the strings only, that in the forward direction, the counting starts from 0, then 1, then 2, then 3 for 34. Similarly, you can have a counting in backward direction, and in a backward direction, uh, the numbering starts from -1. So 34 is at -1 position, 2 as a character is at -2 position, this one string is at -3, and the initial one is at -4. So let's try to print what is at -1 position. Let's save this and run our command. We got 34 printed. As at the -1 position, we have 34. This is the way we access the element and then printed the data variables inside the list. We can also update the variable in a similar way. We can do that using the L variable type of the list, then the index and the location or the position of the element which we want to change. Let's say we want to change the 0th index variable, and right now it is 1, and we want it to be equals to 10. Now let's print our list using L. Now run our command, and as you see, while printing our list, the first variable is no more 1 now, it's 10 now, because we changed the variable at the 0th index to be equals to 10. So it got saved after this line was executed, and then we printed the value of L. Then that's why we got L's first element to be 10 rather than 1. Let's get back to our slides and know more different type of data structures in Python. Next we have is a tuple. Tuple is very similar to list. Just the difference is that here we don't have that feature of updating the values after it was created. So in this way, a tuple acts as a permanent data structure where list acts as a temporary data structure. Let's write our tuple inside the code. We can have t equals to write a tuple, we use parentheses, and within the parentheses, we can give any kind of data structure, any kind of data variable. Let's say we give 1, then 2, then 2, then 3 as an integer, then 4 as a float. Now let's print our t and let's see what we get. After we print our file, we got our tuple to be printed exactly the way we created it here. Now let's try to test our theory that the elements in the tuple don't get updated. Now we use the square bracket on the tuple, and with this operator, within this operator, we give the index of the first position, and we can say this t of 0 should be equals to 1 as an integer. Save our file. As soon as we save our file, you can see a red figure appeared beside T. That indicates that Visual Studio Code has seen this foreseen this error, which we will get while compilation. So as you can see here, the type error, this is the error we get, a type error, which says tuple object does not support assignment. This means you cannot assign any value inside a tuple. So these are exactly how the list works, just that we cannot assign any variable once they get declared. So this was our tuple, and let's get back to our slides and get to know more different type of data structures. Sets in Python are exactly like the mathematical sets, where we have a set in which the elements don't repeat themselves. Here in example, you can see we have created a set using these curly brackets. So to create a set, we just use a name variable, then that is equals to, then we use as curly brackets, and within this curly bracket, we have given some integers. And when we printed this, we got only those integer, but only once. As we saw earlier, the different data structures can have arbitrary type of data variables inside them. They can store any kind of data variables, but that is not true for sets. Sets can have only those elements which are hashable. You don't need to worry about what are the things which are hashable. You just need to know that within the sets you can have right now, you can think of it as you can have only string, a bool, or an integer, or a float, or a characters. So as you can see, you cannot have a list inside the set. Now let's try to run a code and let's try to experiment with the sets. So how we created set is we gave the variable name, then within the curly brackets, we gave the integers. We can give one as many as times we want. And then let's try to print our s, a set variable. Let's open our terminal and we print, and we within the set we got one only once, where we gave it 6 times. This is because the set only keeps a unique values. If we have one in 6 times, the set will not save it for 6 times. It will only save it for one. Now let's try to add a list inside our set and let's see what happens. We can create a list using L variable, then as after a square bracket, we can have 1, 2, and 3 elements inside the list. And within the set, we can have this list given 3 times. Now let's print our set and see what happens. As you can see, we have a type error here. And after that, it says unhashable type, then that is equals to list. This is because list is not a hashable type of data structure. That's why you cannot give a list inside a set. So we can give int, float, character, string. Let's save this and run. We got all those type of variables printed. So this is the string data structures. Let's get back. Sorry, so this is our set data structure. Let's get back to our slides to get to know another data structure in Python. Finally, we have dictionaries in Python. Dictionaries are data structure which stores key and values. Key and value are paired together and they're stored inside a dictionary. So while defining a dictionary, you need a curly bracket, and inside those curly bracket, we need to give a key and a value at the same time. So let's write some code and see how these dictionaries are created inside the Python and what are these keys and values. So as we know, to create a dictionary, we first give a variable name. Our dictionary will be of variable name dict here. Then we use a curly bracket, and within this curly bracket, we can have uh, only keys and values. And how do we give these keys and values? Now, a key can be anything which is a hashable type. We just studied that hashable type are int and floats and strings and etc. So let's give a string here and we can say this is a key. And then we need to add a colon to give our value. A value can also be of any type. So the value, let's say, is some number which can be 1, 2, 3. Let's save this and let's print our dictionary using print. Then within this we have tick, and then let's try to run our code. So in the result we got within the curly brackets we have a key string, then colon, then the number 1, 2, 3. Let's try to give another key and value pair inside our dictionary. We use a comma here, and then you don't need to go to the next line. You can also write anything here, but just that writing in the next line makes it look better. So let's try to give another key. We can say it's key 2, and within the key 2 we have 321 as in value. Let's print it again. You can see, and within the curly brackets, we have key to be 1, 2, 3, then a comma is here, then the key 2 is there with the with the colon. we have the value of 3, 2, 1 after that key 2. This is how we create a key and a value pair inside a dictionary. Now, remember that only keys need to be of a type which can be hashed, which means only the keys need to be of type of int or float or a string, whereas the values can be of any type. So a value can also be a list. So let's try to give a value of list here. Let's try to save our code and run it again here. So as you can see, with this key value, with the key, we have a value of a type list here, which is being printed. Now, as we saw in the list, to access an element, we give the position of that particular element. Here, we don't, in the dictionary, we don't have any position. We can say that there as the position was going from zeroth index till the end. Here the keys are going from zero from in a similar way, so we don't have a number here to give, we have a key to give, and with that particular key, if we can extract the value saved at particular key. So let's try to print what is at key. So as the key was in string format, while extracting the value from this dictionary from that particular key, we must also give it in a string format. They both need to be the same. Let's save it and run our code. So we got our list, which is saved as a value in front of key. Let's try to get the value saved in front of key 2 and that is 321 integer. And let's try to give it some integer and let's see what error we get. As the 1 was not defined as a key for any value inside our definition, so while running our code, we got an error of key error, and which is 1. This is because this one key was not defined. That's why we got this error. So we studied about different type of data structures inside the Python. Now let's use these data structures with a for loop so we can get a better idea about the actual programming. Let's open the text editor and have a small recap for the use of data structures with a for loop. Let's first create a list with a variable name L, and inside this list, let's create some elements. Let's say these are characters with A, B, and C, D being the character elements inside a list. And now let's use for loop to iterate over each element inside the list and print them as they are inside the list. So to do that, we say for loop for then the name of the variable, the iterator, which will iterate over this list. We can say it is a character, let's say C. Then we use in keyword to specify which in which data structure should we go, or in which iterator should we go. Then we use say the L keyword, L variable where we have saved our list. Next we use a colon. Then we go to a next line. This is where we have created the for loop, and to write a code inside the for loop block, then we will write here print C. So what this for loop will does is it creates a variable C. The C variable will have the values of each of these elements inside the list. It is an iterator which will iterate over the list, and it will have all those elements one by one. Let's print this And let's run this file and see what it does. So as expected, we have printed each of the elements of the list here. So let's just understand how we are actually printing each of the element. So the C variable which we created with the for loop, it inside the loop, its values get updated once what with the elements which are inside the list. So at first the C will be equals to A, then C value will be equals to B, then C value will be equals to C element, and the C value finally will have a D. So in this way, the C value gets updated and then we print it. That's why we got A, B, C, and D printed periodically. Now let's try to replace this A at first and let's give it another list inside here. We can give integers inside this list and the remaining code will remain the same. And let's print. Let's run this file again. Let's see what we'll get. We got the list at first position, then the remaining elements were the same as before. So, which means that the C variable is not exactly a character. It can take any form. So as in the list, our first element was list. So the C variable got converted into list and then we printed it. So we got list in the output, and the second iteration it got the C value was updated to B character. So when we print it, we got B. Similarly C and similarly for D. So this is how we can iterate over a list using a for loop. Now let's see how we can do that for a dictionary. Let's create a dictionary using a D name, and within this dictionary we can have key in strings with a key 1 having a value of 1. Then we can have another key 2 with a value key 2, and then key 3 maybe with the value of 3. Now to iterate over a dictionary is a bit different from iterating over a list. There we had elements already inside the list, and while iterating, the values were getting updated according to the way the elements were inside the list. Now when you iterate over D in similar way, you will get keys, not the values. So let's see if we do another for loop like we did for list. We can say for, then a variable C we can replace with the K. For K in D, then let's print K and we'll see what do we get. So we get key 1, key 2, and key 3 printed here. This is because when we iterate over a dictionary, we are actually iterating over the keys. So at first our K variable got a key 1 as a value, then key 2 value, then a key 3 value. And now to extract the values inside a dictionary, we can use another square operator to locate the value with the key value. So what I meant is we can say T dictionary and then we can have a square bracket. Then we can give this key, and what this does is it returns the value saved inside a dictionary with this particular key. Now I'll run our code. Let's see. So at first we printed the key, and then the next line we have the value associated with that key. Similarly for key 2 and key 3 is done. So while iterating over a dictionary, we can have only the key values in a variable, and to extract the value saved with that particular key, we need to use the square operator like this. The other two data structure, the tuple and the set are similar to list. You can iterate over them exactly like list.